All right, team. So I promised we would open Godot today, and that's what we're going to do, but we're still going to be talking about high-level concepts. We're not going to be getting into the nitty-gritty. We're going to talk mostly about where to find information so that you can actually just develop on your own with no tutorials, and you don't have to follow things line by line and try to implement other people's solutions. First things first, we're going to make a new project. We're going to go create. The name doesn't matter. The path doesn't matter. The renderer doesn't matter. You can change that later. For version control metadata, I am going to leave it set to Git, but I use Git separately from the command line, and we will talk about that in part 3. All right, so as soon as we get into Godot, there's a lot going on. I'm going to explain some of it, but all of it's available in other YouTube videos from other people that will go more in depth if you're really deeply confused. So this is our viewport. We can do middle click to orbit around. If we hold right click, we can use W, A, S, and D to fly around. We can use Q and E to go up and down. Sometimes this is a lot better for editing 3D scenes when you can just move through it like a character. You'll see that this is marked as empty, and it wants us to create a root node. We're going to get into that in a minute. There are a lot of settings up here that you should definitely look into in the official documentation or through other videos. It's fun stuff to mess with, but none of it is that important for getting started. For getting started, we need to decide if we are making a 2D game or a 3D game. And for this example, we're going to do 3D, so we're going to go 3D scene. And there we go. Now we have a node. We can hit the run button up here, run project, or run scene. This will make more sense once we make another scene. We'll hit run, and it says no main scene has ever been defined. Do you want to select one? Select current. We're going to name it main. Okay, now it runs and nothing happens, and that's fantastic. For anything to show up, you're going to need a camera. So we're going to go up here to add node, and we're just going to search camera, create. Now we've got this camera, we've kind of got this view. We can click preview to see what it sees. There's nothing to see. So we're going to add a mesh instance, 3D, and then we're going to give that a box mesh. We're going to move it in front of the camera, and then we'll run the game again. Now we can see an unlit cube in the center of a camera. Beautiful. So we also need a light. We're going to use the directional light 3D. This is kind of like a sun. And we can use these little arrows to move things easily. Move it up. If we want to do other things like rotate or scale, we can do those things here, but it's just not that important right now. What we do want to do is look at how this sun is lighting this cube. Regardless of where it is, it's going to do a global directional illumination. So I like to rotate it. I just pressed E to get to rotate there. You can see that E's the hotkey. So then I like to use this here and just come down from above a bit. And that just looks better to me in general. So now we have a cube, and we've got a camera, and we have a light. That is enough for us to get started. I'm going to mess with the camera just a little bit by clicking it here in the scene tree, and then using W to go back to move it up a little bit, move it back a little bit, go back to E to rotate it, down, just so we can get a little overhead view, give it that 3-dimensionality. It's not important, it's just visual, and I didn't want you to get lost. So, what we have in the scene so far is a node 3D, a camera 3D, a mesh instance 3D, a directional light 3D. But how do we know what they do? How do we know what they are? The documentation is the thing. So we're going to go up here and we're going to go to help, go to online documentation. It's going to open this up for us. There are these really good tutorials right here that you can go through that'll take you step by step how to make a little game about dodging some creeps. And it will show you how to make things move and all that sort of stuff. But we're talking about high-level concepts here. I'm just setting a stage so that you can follow with me and understand when I start talking. So if we want to know what a camera 3D does, we're going to search it here, and then we're just going to click it, camera 3D. And this is where that part 1, all the stuff we talked about, understanding the function signatures and inheritance, this is why you need to understand that stuff before you even start in Godot. Here it lists our properties. These are variables that every camera 3D has. So every camera 3D has a call mask. It's an int, an integer. What does the call mask do? There's a little description here of what it does and how to use it. There are videos on YouTube that go way in depth on using every property. And the description here links to several other things that will help you better use and understand this property. So if we go back and we kind of look through what we have here, FOV, far, H offset, we can kind of infer what a lot of these things do. But what I really want to talk about are the methods. These are your functions. Every camera 3D can do these things. We can get information like is position behind and then a world point, and that returns a bool. Now we talked about in the first part return types. It returns a true or false about if the position is behind us. That's really useful. Things like project position can take a position on the camera and turn that into world coordinates. And you can find that out by clicking this and reading about it. This is really good if you want to click things in a 3D scene. This can let you do that. And so going back to our fundamental knowledge, vector 3, that's the return type of the function. So it's going to give us back a position. For arguments, it takes a screen point, which is a vector 2, which is just a pair of numbers. It's just a data type for holding two numbers. It takes a z depth, which is a float, a decimal point number. And these you can get from the mouse. And so if we wanted to point at something with our camera, we could do maybe half of the height, half of the width to make a vector 2, and then z depth 1,000, and that would be the point that we're getting. It's very useful. But what I'm trying to get at here is that all of the things that a camera 3D can do are listed in the documentation. You can just read through here and think of how you would use these things if you are able to read a function signature, which is the return type, the argument types, and a little brief description. Going back to the camera 3D page, there's one more very important part of the documentation page. Up here at the top, we can see the inheritance. It inherits from node 3D, which inherits from node, which inherits from object. It is inherited by XR Camera 3D. So as you recall, this means that XR Camera 3D can do all of the things on this page and then some more. It also means that we get access to everything that node 3D, node, and object can do. So it can be worth clicking through here just to see what it does. We have a global position, we have rotation, and all of that we have access to on our camera because we inherit from node 3D. Most nodes are going to inherit from node 3D or node 2D. If we head back to our scene, what were our other nodes? Mesh Instance 3D and Directional Light 3D. So if we navigate to those in the documentation, we will see that we inherit from Light 3D, which inherits from Visual Instance 3D, which inherits from Node 3D. So we're a couple degrees separated from Node 3D, but there's still useful things that we can do here. It doesn't seem like we have any methods, so no functions that are specific to Directional Light 3D. We have some properties, we have some tutorials here, and we can click up to Light 3D, which might have more useful things in a general way. See, it has methods get correlated color, get param, set param. These could be useful. I don't know. It depends what we're doing. Light energy is a variable that we could just set. And this is how you're going to navigate the documentation. When you have an idea for something, you're going to find a node that is close enough. You're going to investigate what properties and methods it has to do the thing that you're interested in. And if it doesn't exist, then you're going to build your own functions to add on top. But you don't need to watch 90 hours of tutorials to find out how exactly light energy works. You could just click in here and find out. The tutorials are useful because they tell you that this node exists, that Light 3D is a thing, that light energy is a thing. But you don't need to watch super intently and follow step by step exactly how they implement it. You just need to find out that it exists, and then come to the documentation and read about light energy. For OmniLight 3D and Spotlight 3D, changing this value will only change the light color's intensity, not the light's radius. That is the kind of useful information you find in the docs that otherwise might seem like a bug. So going back to Godot, if we wanted to access these properties and do something with them, we need to write a script somewhere. In this case, we're going to be adding a script to the Mesh Instance 3D. And to do that, we just click this little plus script button. We give it a name. We're going to call this cube. There's a lot of stuff here. For now, we're just going to go language GD script, inherits. You could change the type of the node if you wanted to. We're going to stick with Mesh Instance 3D. Template. This I will generally put to empty. I'm going to leave it on default for now because it'll give us some useful information. But templates are not magical. They're just pre-filled out scripts that give you some helpful comments and pre-built functions. That's it. I actually don't have any idea what built-in script does, but we're going to go ahead and leave it unchecked. Path to where we want it. Now res just means our root folder of the project. If you look down here in the File Explorer, that's just where we made our project folder. It's where all our files are going to be kept. And that's kind of a shorthand for like the root directory of this project. And then if you had folders under that, they would work as normal. So we're going to create this, and it's going to open up in the script editor. If you look at these tabs here at the top, we've got 2D, 3D, script, game, and asset lib. We're going to use script for now. So far, we have not talked about syntax at all, and we're not going to go super in-depth on it. We're going to stay kind of high level, but I will explain little bits of GD script right now. So extends mesh instance. That is the inheritance and the includes that we were talking about before. That is the line that gives us all the code that is in mesh instance 3D and lets us use it in this script. So whatever we build now is an extension of mesh instance 3D. Other mesh instance 3Ds will not have access to this code, only things with the cube script. The template went ahead and hooked us up with the ready function and the process function. Now these are written a little differently than the pseudocode that I gave you before. Func tells us it's a function, then the name, and then the arguments, and then this little dashy arrow thing, and then the return type. So the return types are on the right, which is a little different, and then a colon, and then we indent on the next line. This little arrow line here is just showing tabs. That's all. It just shows tabs as though they were a character. Everything that is indented after this func line is inside that function. That is one block of code. The line numbers on the left do not matter. They are just there for your convenience and for errors to tell you where to find the problem. This pass line just means that do nothing. It's just there to kind of pass this line without throwing an error. If we go down here to process, we're going to see delta float. So that means that the argument delta is a float, and then the function return type for process is a void. So we're going to go over to the whiteboard for a minute so I can explain these functions. There's a lot to understand here, and someday we'll write code. All right, so we talked about all this stuff, and I hope you have retained some of it. We're going to talk about Godot entry points. When you write a standalone program in C or Python or something like that, you have an entry point that is standard. It's usually main is the name of the function, and wherever the compiler finds that function is where your program will start. It'll go line by line until it returns, and then your program will exit. When you're working in an engine like Godot, it already is the program. It's already looping. It's making sure that we stay running, and then everything that happens is inside of it. So what Godot does is it provides its own entry points for logic to run. Every frame, it's going to run a couple of functions. Process is going to run at a pretty steady frame rate. It's not going to go crazy. It's not going to be every cycle, and it's not going to be as steady or reliable as physics process. Physics process runs on a very clear timeline. The tick is calculated and it's specific so that things that need to be consistent over many frames and at different frame rates can run in physics process. If I shoot a laser at an enemy, I don't want it to go 3 feet the first frame, 9 feet the next frame, and then 3 feet again. I want it to go 3 feet every frame. So that sort of thing goes into physics process to make sure that it's correct. Input runs anytime a button is pressed. This includes moving the mouse. So if you want to check for something only when a button is pressed, such as which button was pressed, it goes into input. Then there's unhandled input, which is a little different. The scene tree has a standard way of consuming inputs where you can mark them as handled. So that if your UI gets it first, like let's say your pause menu catches the start button, and you just want to unpause the game if that happens, you would put that in unhandled input and then mark it as handled. Nothing else will get the start button because it's already handled. So these are some but not all of our standard entry points into running logic in our game, running our program. We first have to figure out in what process is the appropriate place to do the work that we want to do. If it needs to happen all the time, every frame, it goes in process. If it needs to happen consistently over time, physics process. If it only needs to happen when somebody pushes a button, input. If it only needs to happen once per input, whoever is the top level object, we want to do that in unhandled input. And then signals are for game events. So if the player dies, that can emit a signal that other things can react to without having to call functions directly. But the crux of the issue is that for a normal program, you would just go into main, there would be some code, and then it would return, and that's the end of your program. You just go line by line. In a game engine, it's got a loop set up, and you are inside of another program. And so you have to hook into these things to get your logic done. So going back into the engine, if we look at this template that they set up for us, we have ready, which is one that I forgot about, but it runs when the scene first enters the tree. So if you start the game, this will run one time and one time only. Just to demonstrate this, we're going to have it print out this node's name every time the game starts. So we'll hit enter. And now when we start typing, we're going to get an autocomplete. So we're going to go print, and it's going to bring up all these functions that we have access to from this node. This is a really good way to notice that you are not on the right node. You don't have the right inheritance. If these aren't coming up, you have a problem. So it's kind of like an early warning thing. Let's see what we can do here though. Print orphan nodes, print tree pretty, print. I think we just want to print. So print, and it's going to tell us what arguments. It says that the arguments array. Now that doesn't really make sense to me. So what I'm going to do here is I'm going to hold Control. I'm going to left click print. And it's going to open up the in-engine documentation directly to the function I have a question about. So it's going to tell me here, converts one or more arguments of any type to string in the best way possible and prints them to the console. If we mouse up here, we can see this method supports a variable number of arguments. So this is a fancy print function that can convert like nodes, like Mesh Instance 3D, to a string that it puts out into the console. We can also just put out normal words. So we're actually going to do both. We're going to print self, just to demonstrate that. And then we're also going to print I'm here, daddy. Now, this will auto save when I run. But we can see this asterisk over here on the left that indicates something unsaved. Something has been changed. So the main scene has been changed because we added a script. The script has been changed because we typed some lines. But when we run it, it should all save. And down here in our console, we can see that for the self, it printed out Mesh Instance 3D, Mesh Instance 3D, and our instance number. Then under that, it printed our words, I'm here, daddy. Let's close that out. And there are a few things that I think are worth noting here. So firstly, all the edits are gone now. This is the current state of things that is saved. If we close the program right now, all of that's saved. Also, it only ran one time. If we put it here in process and we run that, you see it runs every frame. Every frame it's printing is catching up, 300. So that's one thing. But another thing is this debugger down here. This is where your errors are going to show up and your warnings. It is my recommendation that you treat warnings like errors. There's kind of like one of those memes with like the beginner and then the expert and then the sage. And treating warnings as errors is one of them. You start out thinking like, I'm going to treat every warning as an error. I'm going to be so good. I'm going to be top of it. Then in the middle, you're kind of like, errors. They're just warnings. I can have 8 million warnings. It's fine. And then on the tail end, once you're super good at programming, you really want things to break loudly where you can see that there's an issue. And you get to the point where you can hide warnings that are not important, and you only get the important ones, which you still want to be errors because they tell you there's a problem. In our case, we're going to click it, and we're going to get all this fancy stuff that you're not going to use until later when you fully understand it. We're going to go to errors. GD script reload, the parameter delta is never used in the function process. If this is intended, prefix it with an underscore. Now that's helpful because we are working on this script right now and we know where it is. And we're not working with 5 different scripts that could all be the problem. But if we were, we could expand this and we can see that it started in cube.gd on line 12. That's very helpful information. If we happen to be up here and we just click this, it'll jump us to the line. And this is where these line numbers start to really matter. If you recall, the delta argument was part of the pre-filled in stuff that the template gave us. So let's just do control and click again into process to see what delta even is. Called on each idle frame prior to rendering and after physics ticks have been processed. That's very useful information. Delta is the time between frames in seconds. So not only does this tell us what delta is, it tells us what units it is in. Knowing it's in seconds instead of milliseconds is valuable information. This is the sort of thing that tutorials are unlikely to cover. You must read the documentation. You must go here and get the actual answers to your questions. For Godot 4, moving from 3.5 to 4, they put a ton of money into getting a third-party GD Quest to rewrite all their docs and be more useful, to be clearer and more verbose. So while some of them are lacking, perhaps, there has been a person that has put actual effort into making the docs useful for you. So we'll go back to the script. And since there's nothing right now that we're actually trying to do based on delta time, we're just going to throw the underscore there and run this again. Get our I'm here papas. And if we scroll up, we can see that our other code still ran one time. I'm here daddy mesh instance. Also, no errors or warnings in the debugger. Just a little insider pro tip, you can do Control and X to delete whole lines. It saves you a ton of time. What I'm going to do now is just give this node a little bit of movement so we can see it moving on the camera and you can get kind of an idea of how that might look. This is not useful code. This is not good code. This is not how we're actually going to move anything as we move forward. Okay, so we've got global position, which we get access to because we inherit from node 3D. And then we're going to do plus equals, which is just a shorthand for this equals itself plus whatever's on the other side. In this case, 1 times delta. And then we get a cube moving, which is great. Another way to access the docs would just be F1 and then search whatever it is you're searching for. And you'll get links to all the things here. If we wanted to know about delta synchronized on the multiplayer synchronizer, we could open the page. So we went over less today. We just kind of went into the editor and looked around, showed you entry points into where you can run your logic, showed you how to figure out what nodes do. And next time we're going to talk about organizing that code in a reasonable way. So next time we're going to use very specific Godot things. We're going to write actual GD script and get an idea of how to implement a feature from no idea to something that runs fine. I will catch you all in the next one.